Okay, welcome back. Let's just check our answers here. So I threw everything I had for A, B, and C into the equation. Wound up simplifying at 24 plus or minus root 780 over negative 6. And then, again, I'm happy if you leave your answer like that, because that's your two possible values for x. If you want to take it further, then what you're going to need to do is then if you want to find the answer to two decimal places, split up your two answers here to one where it's plus root 780, one where it's minus root 780, run them through your calculator, you get negative 8.65 and 0.65. And you might want to do that if you want to use that number to calculate something else, if you want to check your answer and make sure it makes sense with a graph or with a context in a word problem. So if we look at our graph here, again, the graph's not giving the exact points of intersection, but we see it's about negative 8.65 about and 0.65 about. Okay, so again, that means our answer makes sense. Okay, one last example here to look at here. It says find the point of intersection, or potentially points of intersection, between y equals 2 bracket x plus 4 squared minus 5 and y equals bracket x plus 4 3x minus 1. Now, we haven't done much with points of intersection since we did the linear systems unit back at the start of the year. Remember, points of intersection, looking at a graph, we'll be looking for where two things cross each other. So what I've done here is I've created the graph of 2 bracket x plus 4 squared minus 5, so you can see it right there. And here's the graph of y equals x plus 4 times bracket 3x minus 1. And we're looking for the point or points of intersection between these. So I can see one point right around here. Okay, and wondering if these intersect ever again. Now it looks like they might intersect potentially over here as well. Okay, you kind of have to really zoom in to see it, but you can sort of see the spot where those two are going to cross. Now, again, how do we calculate that? Well, let's go back to the idea of solving a system. So we have two equations, two unknowns, and what we did back in linear systems, we solved this using substitution or elimination. Now graphically, we just take a look and we found our points of intersection there. But again, let's take a look at how we could try and do this algebraically using substitution or elimination. Now, with elimination, you might remember we need to have all of our x, y terms and constant terms all lined up so we could try and eliminate something. That looks like it might be a lot of work here. So what I'm going to try and do is use substitution, because I already have a variable isolated, right? I have y equals and y equals. So I can set these two equations equal to each other, potentially. So wherever I see y in this equation, I replace it with 2 bracket x plus 4 squared minus 5, and then I can potentially solve it for x. So I'm going to do that first. So I'm going to have 2 x plus 4 squared minus 5, and over here I'm going to have x plus 4 3x minus 1. Okay, now again what I have now is a quadratic equation. There's only one variable in it, it's x. Now you'll notice here that x appears more than once in the equation, once on the left side and twice on the right side, so I can't just rearrange to solve for x. So I'll treat it like any other quadratic equation I've seen so far, which means I want everything expanded, simplified, brought all over to one side so you have 0 on the other side, and then you can solve for x. Okay, so there's a lot of algebra that goes into this. We have to first expand everything and simplify it. Okay, so I'm going to do that on the left side here first. X plus 4 squared. If I do that in an array, okay, and you can do this on your own as well. You've done tons of arrays by this point in the year. Okay, so it's going to give me x squared plus 8x plus 16 minus 5. Okay, and the right side here I'm going to expand that using an array as well. So I have x plus 4 and 3x minus 1. Okay, so that's going to give me 3x squared plus 11x minus 4. Okay, so again, I still got some work to do. I still have to finish expanding here on the left side. It's going to get 2x squared plus 16x plus 32 minus 5. Okay, right side stays the same. Okay, and then I'm just going to finish collecting my like terms over here. So I get 2x squared plus 16x plus 27. Okay, so at least everything's now expanded on each side, but again, if I want to solve this, I still need to put everything over on one side of the equal sign. so I can have 0 on the other. So I have a choice of moving everything from the right to the left, everything from the left to the right. I'm going to move everything from the left to the right only because I see I have 3x squared, and if I move 2x squared over here, at least my a value is going to be positive. Might make it a little bit easier to work with in quadratic formula, but again, either way will work. I'm going to move everything over to the right side first. So I'm going to subtract 2x squared. Okay, I'm going to take a few steps for this. You may be able to do this all in one step, and if so, great, please do that and save yourself a lot of time. But just to show you that I'm moving everything over here. So I have 3x squared minus 2x squared, so I get x squared. Okay, and I have 16x plus 27 here. Okay, subtract 16x from both sides of the equation now. Okay, so I have just 27 left on the left, and I have x squared minus 5x minus 4. Okay, and then subtract 27. And again, you can very easily skip a lot of these steps and do all of this in one. So I'm going to have 0, x squared, minus 5x, and then minus 31. Okay, and again, you should be able to go straight from here down to here. I just showed all the intermediate steps, but you can move everything over in one step. Okay, so from here, your options are to factor or use quadratic formula. You can try factoring this. It will not work. So you have to use quadratic formula now. Okay, so here's my quadratic formula. I want you to take a second now and just finish this up. Try and find the x-intercepts, or the x values, using the quadratic formula, and push play and ready to see it together. Okay, so take a look, check through the math, make sure you got the same answers as me. Now, these are the two x values I got. I got about 8.60 and negative 3.60. And if you look at our graph, that matches what we got here. We got a point of intersection negative 3.6 and 8.6 on our graph as well using Desmos. So the only thing left here, you gotta be careful to make sure we've actually answered the entire question. It asks for the, well, first of all, it says point. It should say points because there's actually more than one. But a point has both an x and a y value. So we found the x values of both the points of intersection. In this particular case, we need to find the y values as well. So think back to when we solved a linear system, but way back in Unit 1, back in start of the semester. Once we found the x value, we had to sub it into one of our original equations to find the y value. So we're going to do the exact same thing here, but we're going to do it with both of our x values. So let's just say, it depends which one you prefer to work with. Let's say I want to work with factored form right here. So I'm going to take both my x values, sub it in here for x to find my y value. So I have, for each one, y equals, bracket, x plus 4, 3x minus 1. Okay, and for each of these, again, I'm going to sub in the x value into the equation and solve for y. So for this equation, x equals 8.6. For this equation, x equals negative 3.6, approximately. Okay, so I'm not going to have exact answers here. We only could get exact answers by subbing in this entire expression here in for x. But that is a bit more complicated. We're just looking for approximate points of intersection here. So let's work this out here. So I'm going to have y equals 8.6 plus 4, 3 times 8.6 minus 1. Okay, I'll work along with me as we do this here. Okay, this is something you can easily do in your calculator as well. Okay, so I get one y value at 312.48, and over here I get about negative 4.72. So let's see, make sure this matches what I have in my graph. So about negative 4.7 and 312.5, which is what I get here. So for my points of intersection here, remember I gotta state my final answers here. So my POIs, I'm gonna have 8.60 for x, 312.48 for y, and over here I'll have negative 3.60 for x, and negative 4.72 for y. Okay, so nice little application there, but again, we need a quadratic formula because otherwise for each of these situations you have to put it into vertex form to solve for x. This is a much faster approach. Okay, so that's it. That's all. There's some homework there. Again, the quadratic formula just takes some practice getting used to. The one thing I want to watch for here is that now that we know the quadratic formula, now that we know the formula and we know it can solve for the zeros always, often the problem is you revert to using it every single time. Now, remember that with some of the methods we've used already still work. You know, if it's in vertex form, why would you put in a standard form first? We can just rearrange the equation and solve for x when you put in y equals 0. If your equation factors nicely, why would you go through the mess of quadratic formula when you get the x-intercepts very quickly by factoring? So plan ahead, think ahead, and if you can use an easier method, do so, because quadratic formula, while it always works, is not always the fastest way, and you got to make sure you're doing things efficiently. If you're not doing things efficiently, you can do things like accidentally run out of time on a test, or using a tool like quadratic formula is nice, but it's easy to make a mistake algebraically with all the messy stuff that goes on inside that equation, especially in the discriminant. So again, look for the fastest, best way to solve a problem. Don't always revert to using the quadratic formula just because it always works. Okay, so you'll notice here for number 5 in your textbook, I said use the best method, not necessarily quadratic formula. Keep that in mind as you're solving. Okay, so that's it. That's all, and we'll continue on when you're ready.